This is the prototype of an IoT LED ceiling light which I've been developing over a few years. It can be controlled by any device such as a smartphone, a tablet, or a laptop. On top of plain white light, the lamp also features RGB LEDs so that color can be customized. This video will cover the various design and implementation details of this project. The light is built around an aluminum extrusion. It features two sets of LEDs. COB LEDs for white light in the center, surrounded by strips of RGB LEDs for colors. It attaches to the ceiling and receives AC power using this socket, which is commonly found in Japan. The socket is linked to the aluminum extrusion using a 3D printed part. The LEDs run on 12V DC, which are provided by this power supply. Last but not least, this PCB provides the light with IoT capabilities. The schematics, as well as layout for the PCB, have been designed in EasyEDA. Those have been made open source and available on OSHW Lab. The boards have been manufactured by JLC PCB. And here's the result after all the components have been soldered on. The main component of the board is a Wemos D1 Mini, which is in fact a breakout board for an ESP8266. The ESP8266 allows the lights to connect to Wi-Fi and be controlled over HTTP or MQTT. The PCB receives 12V from the power supply through this connector. Those are then stepped down to 5V for the Wemos to use using this buck converter. The Wemos drives those 4 MOSFETs, each of which controlling an LED channel. 1 for white light and 3 for the RGB LEDs. The MOSFETs are driven using PWM to provide a dimming feature. The board also features a photoresistor to measure illuminance and includes a connector for a motion sensor. The firmware running on the ESP8266 has been written as an Arduino sketch. It handles Wi-Fi connection, HTTP, MQTT, as well as reading sensor information. The code is open source and available on GitHub. The ESP8266 acts as a web server and serves several pages. The main web page allows for the configuration of the device with settings such as Wi-Fi or MQTT. The light can be turned on and off using HTTP post requests. Those can be sent using a dedicated page. The web interface also allows to control the intensity of each LED channel, which allows the color of the light to be tuned. On top of HTTP, the light can also be controlled via MQTT. This makes it compatible with various home automation applications. Here is an example with a smart home control panel which I've designed. Similarly, the light can also be integrated in applications like HomeAssistant. As mentioned before, the PCB also includes a photoresistor to measure illuminance. This illuminance is periodically published via MQTT. In this example, the illuminance is recorded and then displayed on a Grafana dashboard. As the room gets darker, one can clearly see that the illuminance drops accordingly. This is another, smaller version of the ceiling light. It includes a motion sensor underneath it, which is connected to the corresponding connector of the PCB. With those two sensors, various automations can be designed. For example, turning the lights on in a room if someone is present, but only if illuminance is sufficiently low. I've been using those lights for a few years now, and they've been working without major issues so far. If you're interested in this project, please check the links in the video description, and thank you so much for watching.